So 8th graders, we are doing section 5-7. This is called indirect measurement. So indirect measurement is where we can find the measure of something without measuring it directly, based on the fact that we know that they are similar figures. Okay? So you guys have actually kind of practiced this with triangles already. And so the biggest thing is being able to set up a proportion. So it says triangles A, B, C, and E, F, G are similar. So we know these shapes are similar. So when you are missing a side, you can use a proportion with the known sides and solve for the missing side. So if I were to set this up, and like I said before, I kind of like to do it in relation with these shapes. So maybe I would do 3. And what side does 3 match with? It matches with 9. These sides go together. And then 4 goes back to that smaller triangle, goes with X. So we don't know what X is. And then this is where we use our cross products. So 9 times 4 is 36. 36 divided by 3 is 12. So that means that X would be 12 feet. You could. I'm just preparing you to set it up in case they're not nice numbers. Okay. So we've been doing it with triangles and other shapes, but we can apply this to items like this. This is something that works, okay? So it says a 30-foot building casts a shadow that's 75 feet. So at the same time, a tree casts a shadow that's 35 feet. So one thing that I like to do when I set up these problems is label a couple of things. So if we're doing this, maybe we could do like the building, and then we've got our tree over here. And then we have the actual height of the building, and we have the shadow of that building. And that's gonna be true for the tree as well. And then I kind of do this like fill in the blanks. So what's the actual height of my building? 30 feet. What's the shadow of the building? 75 feet. Do we know the actual height of the tree? No. Do we know the shadow of the tree? Yep. 35 feet. Okay, and then this is where we would do the calculation. And there's my calculator. So I would do 35 times 30 divided by 75. And I get 14. Always make sure that your answer seems logical. It looks like the shadow is taller than the building, so then our tree shadow should be taller than our tree. Is that the case? Yes, so we are accurate. So the only different types of problems that you'll have are some that they don't give you the actual drawing. So this is where your artistic ability comes in and you get to draw on your own. So it says a flagpole casts a 32-foot shadow. Okay, so we've got a flag pole. Okay, and you guys like that, don't you? It's beautiful. Okay. And this flagpole casts a 32-foot shadow. While a 6-foot tall man, so we've got a man over here. We know that he is 6 feet because that's what it told us. Casts a shadow that is 4.5 feet. So again, I'm going to set up this proportion. And I am going to do actual, shadow, and then I'm going to have the flagpole and the man. That's kind of how I set it up. Do I know the actual height of the flagpole? No. So that's my X. Do I know the shadow of the flagpole? Yeah. Do I know the actual height of the man? Yes. Yep. 6 feet, and then the shadow of the man is 4.5 feet. So then you can take, cross multiply 32 times 6, and I get 192 divided by 4.5, and I get 42.67. I'm going to just check 32 times 6 divided by 4.5. Yep. So how tall is the pole? 42.67 feet tall. Okay, letter B. A 40-foot tall monument casts a shadow that just reaches the base of a 4-foot tall parking meter. Okay, so I don't really know what this monument's gonna look like. We're just gonna pretend this is the monument, okay? Beautiful, right? We know that this monument is 40 feet tall. And we know that it's going to cast a shadow that goes as far as the base of this parking meter. So I've got a parking meter right here. Okay, and it says 4-foot tall parking meter. So I'm going to make sure I note that that's 4 feet tall. Okay, if the parking meter's shadow is 6.5, how far apart is the monument and the parking meter? We can find this distance because really what they're asking for is how far is the shadow? How big is the shadow of the monument, right? So when I set up my problem, I'm going to do my proportion. And I have actual to shadow. And then I have monument to parking meter. And now I can put in information. So do I know the actual height of the monument? Yes. Yep. 40 feet. Do I know the shadow of the monument? No. Do I know the actual height of the parking meter? Yeah. Yep. Do I know the shadow of the parking meter? Yep. So then 6.5 times 40 divided by 4, and I get 65 feet. Is the distance between the parking meter and the monument.